Tonight's lesson is identifying proportional and non-proportional relationships in tables. We worked on this quite a bit last night, and now we're just going to revisit quick tonight. My hope is by the end of this video lesson, you'll be very comfortable analyzing two ratios to determine if they're proportional to one another if the values are given in a table. Let's take a look at this example. Is distance traveled proportional to time? Well, hopefully you remember from last night. If I can find a constant value to multiply each of my times by to get the corresponding distance traveled, I have a proportional relationship. So we're trying to find a value here to multiply by every time. 1 times what is 30? Well, 1 times 30 is 30. If every time I take my time and multiply by 30, I get the corresponding distance, I know I have a proportional relationship. So let's just check. 2 times 30 is 60. 3 times 30 is 90. And finally, 4 times 30 is 120. Because I multiplied by a constant value every time, in this case 30, I definitely have a proportional relationship. It was pretty easy to determine the value to come up with for this example because we had 1 in our table. So 1 times what is 30 gave us an easy way to figure out the value to try to multiply by each time. That won't always be the case. Sometimes you're dealing with fractions and decimals that you need to try to multiply by, and then it's not easy to come up with. So we talked about a strategy last night, and I just want to revisit it tonight. If you can't quickly determine what to multiply by, what you're going to want to do is you're going to want to take your second quantity, in this case distance, divide it by the first quantity, in this case time, and that'll tell you what to try to multiply by. So I'm just going to take one of the distances. I'm going to take the 120. So I'm going to do 120 miles. And I'm going to divide by the corresponding time. Well, what corresponds to 120 miles? 4 hours. And I'm going to go ahead and divide that out. You can use your calculator if you need. 120 divided by 4 is actually 30. So that's 30 miles per hour. And what that 30 actually is our constant unit rate. Every hour that car travels, they're going to be going 30 miles. So that's a proportional relationship. It has a constant unit rate. This is the first example that after we read it over together, I'm going to have you try it on your own. It says, Kayla made observations about the selling price of a new brand of coffee that sold in 3 different sized bags. She recorded those observations in the following table. 6 ounces of coffee was $2.10, 8 ounces was $2.80, and 16 ounces was $5.60. Is the price proportional to the amount of coffee? Why or why not? Take a minute, pause the video, try it out, come on back. Okay, hopefully you paused the video and tried this on your own. You remember from last night, if this is a proportional relationship, we should be able to find a constant value such that when we multiply each of our ounces by that constant number, we come up with the corresponding price for the bag of coffee. If I look here and try to say 6 times what is 210? That's a tough one to come up with right off the bat. Some of you have it right away, but for some of us it's hard to figure out times what because it's going to be a decimal. And so I'm going to take a look over here and I'm going to say, okay, I'm going to take my price in dollars and I'm going to divide by my ounces. So I'm going to take my $2.10 and I'm going to divide by my 6 ounces. I'm going to divide that out. You can use your calculator. I'm going to take 210, divide it by 6, and I actually find that that bag of coffee is 35 cents per ounce. That gives me the value to try to multiply by. So right here I know 6 times 0.35 gives me 210. I'm hoping that 8 times 0.35 gives me 280, and that 16 times 0.35 gives me 560. If it's 35 cents per ounce in each bag, that means this is a proportional relationship. So on my calculator, I'm just going to do 8 times 0.35. Hey, it's 2.8. It is $2.80. Now finally, 16 times 0.35. Yes, it's 5.6 or $5.60. This, yes, is a proportional relationship. Yes, it's totally proportional. And how do we know it's proportional? Because if I take my number of ounces, I can always multiply by 0.35 to get my cost for the coffee. And because we have a constant value we multiply by every time, this 35 cents per ounce, it's guaranteed it's proportional. Let's see if we can use that relationship to predict the cost of a 20-ounce bag of coffee. So now instead of 16 ounces or 8 ounces or 6 ounces, I want to predict the cost of a 20-ounce bag of coffee. Pause the video, try it out, and come on back. Okay, hopefully you pause the video. You can go back to the relationship. You know if you take the number of ounces and multiply by 35 cents per ounce, you're going to get the cost. This time I tell you take 20 ounces. Each of those 20 ounces is 35 cents a piece. So 20 times 35, use your calculator if you need. 20 times 0.35 is actually $7. So the cost is actually $7. Some of you just continued the table and you said, oh, I just take the 20 and I multiply by 0.35, and you absolutely came up with $7 for that bag of coffee. Let's take a look at another example. This one's about selling cars. When a salesperson sells cars, they earn what's called commission. They earn a little bit of money every time they sell a car, and that's how they make their money. So the table below shows the relationship between the number of cars sold and the money earned for a car salesperson. Is the money earned proportional to the number of cars sold? Explain why or why not. So I need you to pause the video, try this out, come on back, and we'll try it together. All right, hopefully you paused the video. So if this relationship is proportional, we should have some constant value that we can multiply the number of cars sold by to get the corresponding money earned. Well, there's a 1 in the table, so it's pretty straightforward. 1 times what is 250? Well, 1 times 250 is 250. If 2 times 250 is 600, this might be proportional. And then we'll try 3 times 250. Let's try the 2. So you can use your calculator if you need. 2 times 250. Oh no, that's 500. Oh no, it's actually 2 times 300 gets us to 600. And as soon as these numbers here differ that you're multiplying by, there's no constant value to multiply the number of cars to get the corresponding money earned, so this is not a proportional relationship. And it's as simple as that to decide if a relationship is proportional. If there's not a constant value to multiply by every single time, it's not going to be proportional. Let's take a look at the same example. Now we know the relationship's not proportional, but can you still use that table to try to predict the money a salesperson will earn for selling 10 cars? What I need for you to do is pause the video, try it out, and come on back. Hopefully you paused the video. I'm going to tell you, because the relationship's not proportional, we're not going to be able to predict. No, we can't predict from this table. No, we can't predict the money earned for selling 10 cars because the relationship is not proportional. And I'll tell you, normally when you're selling cars, it's not about the number of cars you sell, it's about the cost of the cars you sell. So in this case, maybe the first car was $20,000 and he happened to earn $250 for selling that. Maybe the second car he sold was $30,000. So he actually sold a bit more, or he earned a bit more money for selling that second car. So you can't predict just based on how many cars. You might have to use the value of each of those cars to predict how much the person will make for selling them. So that's not proportional. You cannot predict. Here's our focus question that I'd like you to try to write a nice write-up for to bring to class tomorrow to share. It says, why is it helpful to know if a table of values represents a proportional relationship? How did knowing the coffee was proportional, the number of ounces of coffee was proportional to cost, how did that help us predict how much a 20-ounce bag would cost? And why could we not predict for the 10 cars how much the person would earn? Why is it helpful to know if it's a proportional relationship to be able to make some predictions? So try to do a nice write-up on that, and we'll go over it tomorrow in class. Have a good night.